In this example of differentiation, we're going to look at what is known as the product rule. The product rule is where we have some function, just describe it as y, is equal to some function u of x times another function v of x. And so we can identify a function like that. For instance, maybe y equals 5x times sine x. So here would be u of x, and the second one would be v of x. Or another example would be y equals 3x plus 2 to the power of 4 times 5x squared plus 6x to the power of 3. Now, in theory, what we could do is expand out the two brackets, the 3x plus 2 all to the power of 4 times the 5x squared plus 6x all to the power of 3, gather all your terms, and then do some individual differentiation of each of the terms. But that would be rather long-winded, to say the least. So what we do is we see, well, look, this is a function in x that we can separate out. I will call that u. And here's another function in x, we'll call that v. So v of x. So the rule for the product rule is that y equals uv, where dy by dx equals v du by dx plus u times dv by dx. If you always follow that set pattern, you'll be fine. So what we do is we identify u, we identify v, we then differentiate each of those terms with respect to x, and then gather all the terms together. So what we'll do is we'll take the example, the second one I showed you, y equals 3x plus 2 all to the power of 4 times 5x squared plus 6x to the power of 3. So y equals 3x plus 2, all to the power of 4 times 5x squared plus 6x all to the power of 3. So I'm dividing them out now. There's u, there's v. So u equals 3x plus 2 to the power of 4, and v equals 5x squared plus 6x to the power of 3. Now you'll see that each of these terms, u and v, we have to use the chain rule to differentiate them. So sometimes whenever you're using something like the product rule, you have to take your work off to the side, work it out, and then bring it back into the main calculation to give you their solution. Excuse me. So looking at u equals 3x plus 2 to the power of 4, du by dx equals, so I take the 4, write it down. Write down contents of the brackets, reduce the power by 1, and differentiate what's inside the brackets. So differentiate 3x, you get 3. Differentiate 2, you get 0. So it's just times 3. So I'm just going to tidy that up. Du by dx equals 4 times 3 is 12 on 3x plus 2 to the power of 3. Similarly, we now look at v. v equals 5x squared plus 6x all to the power of 3. So dv by dx equals, so I take the 3, write it down. I'll write down the contents of the brackets, 5x squared plus 6x, and I reduce the power by 1, so 3 goes to a 2. And now we look inside the brackets, the original brackets, and we differentiate the contents. So I now differentiate 5x squared. That becomes 5 times 2 is 10x. Differentiate 6x, that just becomes 6. So I suppose I could just tidy up a little bit here. dv by dx equals 5x squared plus 6x all squared. And then in the brackets, 3 times 10x is 30x, 3 times 6 is 18. So keep it like that. So now you can see that we've developed u, we've got v, we've got du by dx, we've got dv by dx, and those are all the terms that are needed for the product rule. So now we go dy by dx equals, Our first term is v. It's 5x squared plus 6x all to the power of 3 times du by dx, and du by dx is 12 on 3x plus 2 to the power of 3. So that's v du by dx. We then put in our plus sign and we look now at our u term. So u is 3x plus 2 to the power of 4. So u times dv by dx, and dv by dx is this term 5x squared plus 6x all to the power of 2 on 30x plus 18. So 5x squared plus 6x to the power of 2 on 30x plus 18. And that's that. We could take out common terms and so on, simplify further, but as far as we're concerned at the moment, this is the product rule has been applied and we have now differentiated the original function. Thank you.